Hello friends, today I shall discuss about a important topic on mathematics, that is derivative. It is very much important for plus 2 science students as well as for plus 3 science students and also for plus 2 art students, and also in CBSE pattern it is very important for 11th class as well as 12th class. About the engineering students, it is also very much helpful for them. So, without spending much time on this, today we shall discuss about our derivatives. Before going to discuss about derivative, we have to recall our formulas that I have already given on another video. Still, I am going to that formulas first. Then we will start our today's topic, that is derivative. It is a long topic and different type of derivatives are there, like trigonometric functions, inverse functions, implicit functions, direct rules, and about the composite rules. So various type of derivatives have some different type of formulas. So first of all we have to go one by one. So I am requesting you all to watch the video till the end. Then only you can able to solve all the problems at your fingertips. I assure that if you complete this video once, then definitely you will score good marks in your derivatives. So today we shall discuss about derivative. Okay, this is derivative. So what I mean to say, whenever we are discussing about derivative, first of all there is some functions. Generally we are using x as the function of variables. So we are many times we are using d by dx for derivative. That means first I am discussing about the formulas that we will use today. Then chapter I will recall you the formulas and we will solve some problems also based on the formulas. Okay. Now d by dx of x to the power n. D by dx of x to the power n. N is a constant and x is the variable. So it becomes n x to the power n minus 1. Okay, n x to the power n minus 7. Similarly, d by dx of a to the power x, that is equal to a to the x ln a. Ln a. Ln means logarithm with basic e. Similarly, d by dx of e to the power x, that is equal to e to the power x. Okay. Now we will discuss some trigonometric formulas and we have to need those one, because during the time of teaching or reading we have to we need those ones. D by dx of sin x, that is equal to cos x. D by dx of sin x, that is equal to cos x. D by dx of cos x is equal to minus sin x. Okay, d by dx of tan x, that is equal to sec square x. Okay, d by dx of sec x, that is equal to sec x into tan x. Okay, there is some. Okay, now d by dx of cot x is equal to minus cosec square x. Okay, d by dx of cosec x is equal to minus cosec x into cot x. These six are trigonometric functions, and during the solution, during making any kind of problems and solving those one, these six formulas must be necessary. So you have to remember these formulas. Now I am omitting these things. Okay. Before going to discuss about these derivatives, we need four formulas which are most important. That is dy dx of u plus v. What is this u and v? U is a function of x and v also a function of x. That means it becomes dy dx of u plus dy dx of v. That means derivative u plus derivative v. Similarly, dy dx of u minus v. U is a function of x, v also a function of x. So here we have taken with respect to x. This is equal to dy dx of u minus dy dx of v. Okay, now dy dx of u into v. If it is on multiplication, what shall we do? Now we have to keep one and taking the derivative of other. That means u dy dx of v. Okay, plus v dy dx of u. Okay, u derivative of v, u derivative of v plus v derivative of u. If there are more than two functions, that means if it is dy dx of u, v, w. Here there are three functions. Then what shall we do? We have to keep two out of them as constant, like constant, and taking the derivative of third one. Okay, u, v, dy dx of w. Okay, plus u, w, dy dx of v. Okay, plus u, v, w, dy dx of u. Okay, keeping two outside, taking the derivative of w, keeping now these two outside, taking the derivative of v, taking these two outside and taking the derivative of u. This is for three functions. Similarly, we can take different functions, and basically in class 2 we have two or three multiplication simultaneously. And another one formula, that is important formula for division. In division we are using dy dx of u by v. Here u is a function of x and v also a function of x. Then we can write v dy dx of u minus u dy dx of v by v square. Okay, derivative u by v. U is on numerator, v is on denominator. Then the formula is v derivative of u minus u derivative of v by v square. Okay, v derivative of u minus u derivative of v by v square. These four formula are most important and very important for us to discuss about these derivatives. Now we will solve some problems depending on these formulas. It is very interesting to know the derivative, because if you can solve these derivative problems, then only you can solve the integration problem. Because if you are finding after completing your derivative and starting integration, you will see that integration is exactly opposite that of the derivative. You will find some formulas, and it is good to memorize first derivatives. So I am taking few solutions, but few questions. Let dy dx of x to the power 6, different type of questions I am taking. Dy dx of x to the 6, x to the power 7 by 2 plus x to the power 3 by 5 minus 2 by 3 x to the power 5. This is a problem where there are some additions, there are some subtraction. So first I am thinking about this addition and subtraction, and it can be easily solved by separating these things. Dy dx of x to the 6 plus dy dx of x to the power 7 by 2 plus, first we have to separate this, dy dx of x to the power 3 by 5 and 2 by 3 is a constant, keeping outside. So dy dx of x to the power 5. Okay, as I have told you that the formula dy dx of x to the power n is equal to n x to the power n minus 1, where n is the constant. Similarly here we have to put these formulas. Here n is 6, so it becomes 6 into x to the power 6 minus 1. In initial set we have to memorize this type of things so that in next questions you can easily solve these things. And you have to remember how the results come. Here n is 7 by 2, so 7 by 2 x to the power 7 by 2 minus 1. Okay. This is also similarly 3 by 5 x to the power 3 by 5 minus 1. Now it becomes 2 by 3 x to the power 5 minus 1. Okay. So it becomes 6 x to the power 6 minus 1, that is 5, plus 7 by 2 x to the power. You can take the LCM of this. It becomes 7 minus 2 by 7 minus 2 by 2. That means 5 by 2. Okay. You can take this LCM. It becomes 7 minus 2 by 2. So 7 minus 2, that is 5 by 2. Now I am from here 3 by 5 x to the power. Similarly, you can take here also the LCM. LCM 5. So it becomes 3 minus 5 by 5. That means 3 minus 5, that means minus 2 by 5. Minus 2 by 5. Yes, here also 2 by 3 x to the power 4. This is your answer. That means for this type of problem, you can easily solve this problem by this formula. Okay. Now we shall discuss some more problems so that you can get some easy way to find out the solution to these problems. Never be worried about. There are some formulas. This is based on your addition and subtraction. Now I am taking one question which is based on multiplication. Let d by dx of x square equal sin x. Just check. Here x square and sin x. There are two functions. X square is algebraic function. Sin x is trigonometric function. So we have to take the u and v method. That means derivative of u into v. So as we know, the derivative of u into v is equal to u derivative of v plus v derivative of u. So we can take this x square d by dx of sin x plus sin x d by dx of x square. Okay. Take the bracket for your clarification. You can easily find out this is x square. Now the derivative of sin x, as we have discussed before, this is the derivative of sin x is cos x. So it becomes cos x plus sin x. Now the derivative of x square, 2x to the power 2 minus 1, that is x, 2x. Okay, so we can write this as x square cos x plus 2x sin x. It is on multiplication. So similarly, you can get more this type of problems. You can solve easily by this method. That means d by dx of u into v method. So that means multiplication. Here we have discussed u d by dx of v plus v d by dx of u. Okay. If you have some more functions here u, v, w, then you can put 2 out of them and taking the derivative of third one. Okay. This is based on this multiplication. Now we will take a question on your division method. Okay, division. Yes, d by dx of x square minus 5 by x square plus 4. Okay, here you can see here is u and here is v. So this is a function on numerator and this is also a function on denominator. Denominator, that means you have to take the method u by v. As you know, d by dx of u by v, that is equal to v d by dx of u minus u d by dx of v by v square. Okay, this is the formula we have to put here. By this method, we can solve this type of problem. So I am taking here u and this is v. So v derivative u. V means x square plus 4. V derivative u. d by dx of u. U here x square minus 5. X square minus 5. Okay. D derivative minus u. U means x square minus 5 into d by dx of x square plus 4. X square plus. Okay. Now divided by this square, that means x square plus 4 whole square. Okay. Now we have to put the x square plus 4, the derivative of x square. You can easily put the formula. X square means 2x. 2x. Now the derivative of the constant is 0. Derivative of the constant is 0. So here 5 is constant, so it can be written 0. Now x square minus 5 and derivative of x square, that is 2x. Derivative of x square. Now taking derivative of 4, that is also constant, so it becomes 0. Here we find x square plus 4 whole square. You have to write the things. Here 2x minus 4, that means 2x. We have to multiply this one. 2x into x square, 2x cube plus 4 into 2x, that is 8x. Now minus 2x into x square, that is 2x cube. Okay. Minus minus plus 5 into 2x, that is 10x by x square plus 4 whole square. Okay. Now we can write here 2x cube cancelling out. So remaining is 8x plus 10x, that is 18x by x square plus 4 whole square. This is the process of division. Okay. In division, we have to use this formula u by v. That means one function is on u, another function is v. That is, this is a numerator and denominator. So follow this formula. Now erasing this one. Okay. This is on all our about direct methods. So there are some questions which we have to solve by composite functions, composite derivatives. What is this composite derivative? Sometimes the problem are there which we can not solve by direct method. In that process, we have to take some variables into other name. After that, we have to take both sides derivative and we have to multiply that one. See what I am doing. Y is equal to let x square plus 5 whole cube. See, y is equal to x square plus 5 whole cube. So we have to find out, the question is find out dy by dx. As we know, if it is x, then we can put the x cube formula. But as it is here, some functions are there. Then you can easily, I am omitting this one, we will find it later. We can use taking this one as some other variables. That means let, as it is a bracket, we can change this one x square plus 5 as u. Okay, so it becomes y is equal to u to the power 3. Here the variable is u, so we can find out dy by du. So dy by du is equal to 3 u to the power 3 minus 1. It becomes 3 u to the power 2. Okay, here we can find out du by dx, as u is here and x is the variable. So du by dx, that means the derivative of d by dx of x square plus 5. Okay, taking this set, yes, it can be easily taken this set u is equal. So it will be more easier to recognize. Du by dx is equal to d by dx of x square plus 5. So derivative of x square is equal to 2x. Similar, derivative of constant is equal to 0. That means it becomes 2x. Okay, now we have to find out dy by dx. How can we find out this dy by dx? Okay, now just I am taking this one. Okay, how we can solve this dy by dx? Dy by dx is equal to, see, this is a solution, this is another solution. For your understanding, I am writing this one. Dy by dx is equal to dy by du into du by dx. Du by dx. See, dy by du is equal to 3 u to the u square. We can change this one as here 3 u to the power 2. U means x square plus 5. So we can put here x square plus 5 whole square into du by dx. Du by dx, that is 2x. So it becomes 2 into 3, that is 6x into x square plus 5 whole square. Okay, this is all about our dy by dx. That means this is a composite function. Why we told it composite? Because we have to take these things. That means here we cannot put this one indirectly. Yes, we can solve it by direct method. I will tell you how to put this one in direct method, but this is the easiest way. In bigger question, we can change these variables to another variable, and we can take this side derivative and this side and multiply both. So in this method, du cancelling out, so dy by dx. The answer is here. So I am taking another problem. Let y is equal to x square plus 5x plus 3 whole cube. Okay, here we can put this one as another variable for your simplification. So let, I have taken, let u is equal to x square plus 5x plus 3. Okay, I change this one x square plus 5x plus 3 as u for my convenience. You can put v as you wish. Okay, now it becomes y is equal to u to the power 3. So dy by du becomes 3u to the power 3 minus 1, that is 3u to the power 2. Okay, this is one side. We have to take the derivative of this side also. That becomes du by dx. That means as here x is the variable, so we have taken derivative of u with respect to x. It becomes derivative of x square, that is equal to 2x. Derivative of 5x, 5 is constant, derivative of x is equal to 1, so it becomes 5. And derivative of 3, that is a constant, equal to 0. So it becomes 2x plus 5. Okay. Now here dy by du and here du by dx. But our question is find dy by dx. Okay. How we can find this dy by dx? If we are multiplying these two, we will find dy by dx. Okay. Here dy by du into du by dx. So dy by du is equal to 3u square into dy by dx, that is 2x plus 5. Now put the values. 3u to u is equal to x square plus 5x plus 3. X square plus 5x plus 3 whole square into 2x plus 5. You can see as du cancelling, so we can find dy by dx. Dy by dx is equal to dy by du into dy by dx. So it becomes this one. This is your composite function. Okay, comment this one. This is all about your composite function. You can go through your books and solve your some problems. If you have any kind of doubt, you can ask me and message me on that video. Okay, then I will try to solve those problems and send to you back. Now we will discuss about inverse function. It is an important, because in integration also you will find some different type of problems on this inverse function. So before going to inverse function, I am first giving some formulas for your memory. Derivative of inverse Okay, derivative of inverse function. Now the formulas, there are 6 formulas you have to remember. That is dy by dx of sine inverse x, that is equal to 1 by 1 minus x square root over dy by dx of cos inverse x, that is equal to minus 1 by 1 minus x square root over. Similar dy by dx of tan inverse x, that is equal to 1 by 1 plus x square. There are other 3 formulas are also there. That is d by dx of tan inverse x, that is cot inverse x. So similar to this one, that is equal to minus 1 by 1 plus x square. dy dx of sec inverse x, sec inverse x, that is equal to 1 by modulus of x root over x square minus 1. Similar d by dx of cosec inverse x, that is equal to minus 1 by x mod root over x square minus 1. Okay, write these formulas. It will be very much essential for discussion of derivative of inverse function. Now I am taking some derivatives of different problems. We will discuss 1 or 2 problems based on these: sine inverse, cos inverse, tan inverse, cot inverse. So first you write this one. Okay, I am omitting. Okay. Okay. Phi is equal to x square sine inverse x. Okay. Y is equal to x square sine inverse. Here two functions are there. One is algebraic, another one is inverse function. We have to find out dy by dx. So as two functions are on multiplication, we have to use multiply formula. And also the time of required, we will do or use our formulas. So dy by dx, that means with respect to x, it becomes d by dx of x square sine inverse x. So this is u and this is v. As per our formula, we can change this one. U derivative v, that means x square d by dx of sine inverse x. Okay, plus sine inverse x d by dx of x square. X square d by dx of sine inverse x. Sine inverse x derivative of x square. Now it becomes x square is x square, derivative of sine inverse x, that is equal to 1 by 1 minus x square root over. Now we have to go this side. That means sine inverse x into derivative of x square, that is equal to 2x. So it becomes x square by 1 minus x square root over plus 2x sine inverse x. So this is one kind of inverse formula. We can take some, I am taking some problems from your book. Yes, sine inverse, yes. One problem is here. Yes. Yes, in your book it is a given y is equal to cos inverse, y is equal to cos inverse x minus 1 by x by x plus 1 by x. Sorry, this is not here. X plus 1 by x. This is your problem. Not like this. This is cos inverse. Okay. So here y is equal to cos inverse x minus 1 by x by x plus 1 by x. This is a just thinking problem. Here two functions are there, u by v. So we can put this one somewhere else. But you can, first of all, we have to think here as here denominator x, we have to take some simplified form. Then we can change this one. So take this is cos inverse LCM is x, that means x square minus 1 by, similarly you can take the LCM, LCM is x, so it becomes x square plus 1. Okay, see, here numerator and denominator, here 2x are there, so you can put this one as cos inverse x square minus 1 by x into x by x square plus 1. See, I have taken this one as changing the numerator and denominator, so these are cancelling out. It becomes cos inverse x square minus 1 by x square plus 1. Okay, this becomes cos inverse x square minus 1 by x square plus 1. Okay, now I am just taking this one as y is equal to cos inverse x square minus 1 by x square plus 1. Okay, so we can take this one as u and taking cos inverse formula, erasing this one for your understanding, and taking this again, that is y is equal to cos inverse x square minus 1 by x square plus 1. Okay, now we can change this one as u. So let u is equal to x square minus 1 by x square plus 1. Okay, we have to find out the dy by dx. So before finding out dy by dx, it becomes what? Not cos inverse u. So you have to find dy by du. What is this? Minus 1 by 1 minus u square root over. Keep this one, we will solve this one later. First we have to think this one, because here du by dx we can find out. So going to du by dx. du by dx. What it gives? U by v part, that means v x square plus 1 d by dx of x square minus 1 v dw minus u x square minus 1 d by dx of x square plus 1 by x square plus 1 the whole square. This is the formula. V derivative u minus u derivative v by a square. It becomes x square plus 1 into 2x. Derivative constant is 0. We can leave this one. Minus x square minus 1 derivative x square, that is 2x, and then 1 is equal to 0. Leaving that one, it becomes x square plus 1 whole square. Okay, you can put the values and find some answer, and after that we will go to this one. It becomes 2x cube plus 2x minus 2x cube plus 2x by x square plus 1 whole square. See, 2x cube cancelling out, it becomes what? Now 4x by, here I am writing x square plus 1 whole square. What is that? Now du by dx. So du by dx is this. Now I can rewrite this one. Okay, for our solution, this is the part. I am omitting this one. So du by dx becomes du by dx is equal to this. Now we have to find out dy by dx. dy by dx. Okay, how we can find? That means dy by du, dy by du into du by dx. dy by du into du by dx. Okay, dy by du is equal to minus 1 by 1 minus u square root over into 4x by x square plus 1 whole square. X square plus 1 whole square. Okay, this is equal to minus 1 by 1 minus u. U is equal to x square minus 1 by x square plus 1 whole square root over. Okay, into 4x by x square plus 1 whole square. Okay, you can omit this one because it needs some more work. Now we can take this one minus 1 by, here we can take the LCM, that is x square plus 1 whole square. So LCM, it comes to here, as it here 1 is here, so x square plus 1 whole square minus x square minus 1 whole square, x square minus 1 whole square. Okay, root over into the 4x by x square plus 1 whole square. Okay, now erasing this one, it may require some more places as it is a long problem. So it becomes, as root over here, we can take this one as above minus x square plus 1 square and root over square omitting them. Now it becomes x square plus 1 whole square minus x square minus 1 whole square root over into 4x by x square plus 1 whole square. Okay, here two functions are there, same factors are there, so it becomes minus 4x by, as you know, a plus b whole square minus a minus b whole square is equal to 4ab, so it becomes 4 into a means x square into b means 1 root over. Okay, now it becomes minus 4x by 2x, because the root over of 4 is equal to x square root over is x. Now x cancel out, it becomes minus 2. So it is a long problem where we can solve this type of problems. You will find some big problems on your engineering examinations or different type of competitive examination. So you have to be patient because you will find some answer, but you have to be patient. Now I am erasing this one. Now we are discussing about some changes. That means there are some also some different type of substitution methods. I am giving you some substitution methods, derivatives on substitution. There are some problems on your book where we can change the formula by our needs. So I am taking one formula, one, as you have already known about the sine 2 theta, cos 2 theta formulas, I think, yes. I am writing few formulas. First you read those ones and memorize them, then we will solve. That means sine 2 theta. Okay, that is equal to 2 tan theta by 1 plus tan square theta. That is equal to 1 minus tan square theta by 1 plus tan square theta. Okay, and one another formula, that is equal to tan 2 theta is equal to 2 tan theta by 1 minus tan square theta. Yes, this is three formulas. So just write these on because we will take some problem based on this substitution method, because we have to put this x value and we will find some solutions. See this one. Write down. Okay. Now omitting this one. Based on this problem, I am taking one substitution method. How we can solve the problem by this substitution method? Let y is equal to sine inverse 2x by 1 plus x square. See, this is important factor because you can solve this problem by two different ways. We can change this one as u, so it becomes y is equal to sine inverse u, taking the derivative sine inverse u and taking the derivative by our substitution method. But here some simplified methods are there, so it is called substitution. If you are thinking here sine inverse is there and you can put this, if you are changing the x value and you can solve it by easily method, then that is very easier for us. That means if we take, let x is equal to, okay, tan theta, that means theta is equal to tan inverse x. It will be required, so I have done this one. Change this one, what it becomes? Sine inverse, okay, 2 tan theta by 1 plus tan square theta. As you know, 2 tan theta by 1 plus tan square theta, that is your sine 2 theta. So it becomes sine inverse sine 2 theta. See, sine inverse and sine, it will be sine inverse sine x is equal to x. So sine inverse sine 2 theta is equal to 2 theta. So y is equal to 2 theta. As you know, theta is equal to tan inverse x. Put here tan inverse x. Okay. Now you can find out dy by dx easily. So dy by dx is equal to 2 d by dx of tan inverse x. What it gives? 2 into derivative tan inverse x, that is 1 by 1 plus x square. So it becomes 2 by 1 plus x square. See, this is called a substitution method. It can be easily solved by substituting the value of x. Here we can easily solve this one. We need not require to taking the derivative on two sides and multiplying them. It can be easily solved by solving this way. Okay, right on. I am omitting this one. I am taking one more problem from your book. Yes, y is equal to cos inverse. Y is equal to cos inverse 4x cube minus 3x. Okay, this is also a problem. Here we can take this one as u. One method is there, so it becomes cos inverse u, and you have to take derivative on that side and derivative on this side and solve this one. Okay, that is composite function. But here see, if you are changing, if let x is equal to cos theta, what it gives? See, cos inverse 4 cos 2 theta minus 3 cos theta. Okay, 4 cos 2 theta minus 3 cos theta, which is equal to cos 3 theta. So we can put here cos inverse cos 3 theta. Okay, again we come to the point, cos inverse cos x, that is equal to x. So it becomes y is equal to cos inverse cos, that means 3 theta. So 3 into theta value, that is theta is equal to cos inverse x. Put here theta is equal to cos inverse x. Okay, so dy by dx, what it gives? Now 3 dy by dx of cos inverse x. Okay, it is equal to 3 into derivative cos inverse x, that is equal to minus 1 by 1 minus x square root over. Okay, it gives minus 3 by 1 minus x square root over. This is the process of substitution. You can solve this one also by composite function. Taking this one as u, it becomes cos inverse u, and u is equal to 4x cube minus 3x. Here dy by du, and here du by dx, and multiplying them. So it can be Solving that way also, this is also one method that is called substitution method. So in substitution method, we can solve big problems if they are coming under your formula. If there is some formula, then only we can put those x in different methods. Another one thing is there in derivative, that is implicit function. Implicit derivatives. Okay, it is another one important, because in this type of problem you will find x as well as y in same set. Then what you will do? That means we are taking x square plus y square plus 5 is equal to 0. Find dy by dx. Here what shall we do if x and y are both are present here? Don't worry, you have to take here, as the x is the variable, you have to take derivative with respect to x on both sides. That means d by dx of x square plus y square plus 5 is equal to d by dx of 0. What do you get? Now d by dx of x square plus d by dx of y square plus d by dx of 5 is equal to 0. Okay, just I am opening this formulas. So x square divided 2x, here y is there, but we have taken with respect to x. Just think this is x. If it is x, what is its derivative? That means 2y. Okay, as it is y, we have to take the derivative again of y. That means dy by dx plus constant, that is equal to 0. So see, where is the dy by dx? Here in this function, dy by dx is there. Then keep this one on left side, taking others on the right side. That means 2y dy by dx is equal to minus 2x. Okay, I have taken this 2x to the RHS. It becomes negative. So dy by dx is equal to minus 2x by 2y. Okay, cancelling 2, so it becomes minus x by y. Okay, this is dy by dx, so minus x by y. See, this is the way where we can easily find out the dy by dx. Now, omitting this one, taking another one example for your better understanding. Just I am taking another example. Let x y square plus x square y is equal to 5. Find dy by dx. Okay. See, this is two function on multiplication. This is also two function on multiplication. You have to take the derivative on both sides for this finding. So take dy by dx xy square plus dy by dx x square y is equal to d by dx of 5. Okay. This is given to me, so it becomes x d by dx of y square plus y square d by dx of x u derivative of v plus v derivative of u. Okay, now come to this. Similarly, x square d by dx of y plus y d by dx of x square u derivative of v plus v derivative of u is equal to 0. What you find here? X, the derivative of y square, that is equal to 2y and dy by dx. As here y is a variable here, plus here y square, the derivative of x is equal to 1. I will not written as it is 1. So this is x square, derivative of y dy by dx y. So plus y derivative of x square, that is 2x is equal to 0. Okay. Understand? Y square, so 2y, as it is y is function, so dy by dx is written. Similarly here also, as y is the function, so we have written dy by dx. Omitting these things. Just to see what it becomes, 2xy dy by dx, 2xy dy by dx. Here plus y square. Here plus x square dy by dx plus 2xy is equal to 0. Okay. Find out where is the dy by dx is there. We have to keep dy by dx on one side and taking other variables on other side. So here is one dy by dx, here is one dy by dx. Keep this one on left side. That means x square dy by dx plus 2xy dy by dx. Okay. Now putting this one on right side. Minus y square. This is also minus 2x. We took this one on RHS. This one also on RHS. So it changes the sign. Sorry. So now here dy by dx is there, and also here dy by dx is. We can take common dy by dx. It becomes x square plus 2xy is equal to minus 0 taken common y square plus 2xy. Okay, we have to find out this dy by dx. So what we will is we find, just see, if this dy by dx we are taking dy by dx, it becomes minus, here we can take common y as common y, that means it becomes y plus 2x. Similarly, here we can take x and taking to the RHS, it becomes x, it's common here, so it becomes x plus 2y. Okay, this is our dy by dx. Easily you can solve this type of problem taking x. If we are taking dy by dx, that means if with respect to x, here x is variable and we can take y on outside, and taking those y as again, if we are coming under this problem, then we can take that as dy by dx. Now another one thing is left on derivative, that is logarithm. That is one another important topic, that is logarithm derivative. Okay, logarithm also. Okay, before going to this logarithm, you have to know some logarithm formula, as in many syllabus logarithm is not there in your course, but it is coming under your derivative chapter. How we can solve? Just see, there are some formulas. Log m into n, log m into n, let base is a, is equal to log m base a plus log n base a. That means if multiplication is there, we can write those one in plus. Similarly, log m by n, base may be a, then it becomes log m minus log n. Base, if a is there, then you can put here a. If b is there, you can put. But important thing is log m to the power n. If it is in this manner, then we can base a. Then we can write it n log n base. This is one important thing for our discussion, because in logarithm this formula comes to help us. So I am omitting this one. Taking one problem. Logarithm, yes, y is equal to x to the power sin x. See, this is on x to the power sin x, not x into sin x. If these functions, here function to the power function, that means it is like y is equal to f of x to the power g of x, in this manner. If the functions are in this manner, we have to take the help of logarithm. Here we can take logarithm on both sides. This means ln y is equal to ln x to the power sin x. Okay, so ln x to the sin x, that means comes to sin x into ln x. Here ln m to the power n, so it becomes n log n. Okay, now we can see it becomes like this. So easily we can find out the solution to this type of problem by u into v method. So it becomes taking derivative on both sides, that means d by dx of ln y is equal to d by dx of sin x into ln x. So u into v form. It comes to u into v form. What it gives? It is equal to sin x d by dx of ln x plus ln x d by dx of sin x. Okay, what it becomes? The sin x into ln x derivative, that is equal to 1 by x plus ln x into sin x derivative, that is equal to cos x. Here on LHS. Okay, what it gives? See this one, the derivative of ln y, that is equal to 1 by y dy by dx is equal to sin x by x plus cos x into ln x. Okay, so we have to find out this dy by dx. So taking this y to this side, so dy by dx is equal to y into sin x by x plus cos x ln x. Okay, putting the value of this y, what do we get? See, so y is equal to, we have taken x to the power sin x, and sin x by x plus cos x ln x. This is our dy by dx. Okay, this is about your logarithm function. How we can take the derivative of different logarithm function. I am taking one more problem. After that, we will close this derivative section, and on next class we will discuss about some more problems on this log derivatives. So I am taking another one. Let y is equal to sin x to the power 10x. See, this is a function, this is also a function. What shall we do? Now we have to take the logarithm, that means ln y is equal to ln sin x to the power 10x. So it becomes 10x into ln sin x. Okay, now taking derivative on both sides, d by dx of ln y is equal to d by dx of 10x into ln sin x. So it becomes u into v form. So it gives this first 1 by y dy by dx is equal to here 10x into d by dx of ln sin x. U derivative v plus ln x, ln sin x. Ln sin x into derivative of 10x d by dx of 10x. Okay, u derivative v plus v derivative u. Just omitting few of them here. Perhaps we will find the answer. Now it becomes multiple by this one, because we will find dy by dx is equal to y into 10x derivative ln sin x, that is equal to 1 by sin x into derivative sin x, that is equal to cos x plus here ln sin x into derivative sin 10x, that is equal to sec square x. So putting this value, the value of y, that is equal to, we have taken perhaps sin x to the power 10x into, it becomes sin by cos 10x into cos by sin, that is cot x plus ln sin x into sec square x. Okay, here 10x into cot x is equal to 1. As we know, some simple formula coming, we have to take those one also into count. So it becomes dy by dx is equal to sin x to the power 10x 1 plus ln sin x into sec square x. Okay, this is about your logarithm function. So we have discussed about different type of logarithms, different type of derivatives, like that in direct method, by composite method, by trigonometric method, by inverse method, by substitution method, and by logarithm method. First, you go through this video and try to solve some problem. If you have some problem, please mention on your Dropbox, and I will try to solve those on next video. So see you very soon. Thank you.